Alright, we're going to continue with our video lessons on synthetic polymers. In the last video lesson, we briefly talked about how polymers are made through the addition polymerization reaction. So when you have ethene or ethylene combining together to form a long polymer chain, there is no byproducts, alright? So the double bonds are going to break up in the ethene to form a long polymer chain. And in this video lesson, we're going to talk about condensation polymerization, which means you have two different monomers linking together, and usually you have a loss of water, but it could be a loss of other products as well. So let's get down right to it. Okay. In your syllabus, you're only concerned about two condensation polymers. The first one being nylon, and the second one being terylene. Let me spell that out. Terylene. Okay, so the first one is nylon. Nylon is made by two types of monomers. Dicarboxylic acid, as noted by the two acid carboxylic groups on the left side and the right side of the monomer, and a diamine by an amino group on the left side and the right side of the monomer. Now, in the middle region, I wrote an R. The R could be anything. It could be a long hydrocarbon chain or a short one. It does not matter. And the two R's doesn't have to be the same structure or same formula. It could be anything. So what happens when we put them together? When we put them together, what you will see is a loss of water. We lose one of the OH will come out, and also taking one of the H from the amino group. And what is going to happen then? This little carbon here is now free to form a bond with one of the hydrogens on the diamine monomer. And what we get is now this new bond. You have the carbonyl group, still there from the dicarboxylic acid, and also an amino group, right, from the diamine. And what we see here is a loss of water, a condensation, basically. All right? So that is basically how two monomers come together to form a slightly longer molecule. And the process is repeated again and again and again until we form a long chain, or until one of the reagents run out. All right? Now, terylene is also done the same way. You have a dicarboxylic acid, noted by the same functional groups on the left and the right side, and a dialcohol, noted by the OH on the left and on the right side of the monomer. When they come together, you are also going to see a loss of water. The OH from the carboxylic acid will form a bond with the hydrogen of one of the dialcohols. All right? And again, what we're going to see is that this carbon here is now free to form a bond with the oxygen on the dialcohol. And what we get again is now a new functional group called an ester. Right? So when you form long chains of terylene, what you're going to get is terylene is going to now become a polyester, whereas nylon, having this amine group, amide group, is now called a polyamide. Polyamide. Alright, this is basically it for synthetic polymers. And next video lesson, we're going to talk about briefly about the, or in class, we're going to talk about and discuss about the problems and usefulness of plastics in our world.